This video is over topic 40, numbers 26 through 30, doing area and volume calculations and conversions, all within the US system of measurement. Again, you'll always be given the conversion factors as part of the question. But the main thing to know is when you're converting area two-dimensional, every conversion has to be done twice. For volume three-dimensional, every conversion has to be done 3 times. So you can think of it as doing it 3 times, or you can square the conversion factor or cube the conversion factor. It takes less writing to do the squaring or cubing. So you just square each number and each unit, or cube each number and each unit. So if I start with 3 square feet, and I want to convert that to square inches, if I just put the 1 foot to 12 inches, the square feet and the feet do not cancel each other out. If I want to have square feet, I have to also square each number and each other unit. Significantly, the 12 gets squared then. So then the square feet and the square feet cancel out. Another way to do it is to recognize that square feet means we have feet times feet. So the feet unit is, there's 2 of them. So if I do the 12 inches to 1 foot, that cancels out 1 of them. And then I need to do it again to cancel out the second one. And then I have inch times inch, and that's square inches. Either way, I'm taking 3 times 12 squared, or 3 times 12 times 12 again. 432 square inches. All right, and then with a cubic, now this is with metric and mix of metric and US, but 1500 cubic centimeters to cubic inches. I start with the 1500 cubic centimeters, or write it out as the centimeter unit repeated 3 times. So if I'm doing the 2.54 centimeters on the bottom to 1 inch on the top, to do the cubic centimeters, I need to cube the centimeters. That means I need to cube the 2.54, and that'll give me the cube inches, and the 1 cube doesn't do anything. It still just comes out 1. Or if I write out the centimeters 3 times, then when I do the 1 inch and the 2.54 centimeters, that cancels 1 of them, and I need to do it again. 1 inch over 2.54 centimeters, cancel another centimeters, and do it again to cancel the last centimeters. Then I have inch times inch times inch, which is cubic inches. So I'm taking 1500 divided by 2.54 cubed, or 1500 divided by 2.54 divided by 2.54 again, divided by 2.54 again, or 1500 over on top of a fraction. The bottom of the fraction is 2.54 times 2.54 times 2.54. Just depends on the calculator you're using and how you prefer to use it. I'm going to do on this 1500 divided by 2.54, and I'll do it here. Oops. 4. Enter instead of. All right, so 91.5. Round that, doesn't say, so just pick, I'll round that to a tenth. So 91.5 cubic inches. Number 28, a 60-inch wide screen TV. It has a screen area of 1,546 square inches. How many square feet is that? So I'm starting with the 1546 square inches. And I have 12 inches on the bottom to 1 foot. I don't just have inches, though. I have square inches. So I'm going to square the inch, square the 12, square the 1, square the feet. So my square inches cancel. And I'm going to take 1546 divided by 12 squared. or 1546 divided by 12 and divided by 12 again, or 1546 over 12 times 12. 10.74 rounded to the nearest hundredth. Square feet. Right, number 29, Jane's living room is a rectangle 17 feet wide and 20 feet long with wooden floors. She wants to treat the floor with 3 coats of polyurethane. 1 can of polyurethane will provide 1 coat over 150 square feet. She doesn't have any polyurethane to begin with. She can't buy part of a can. So how many cans does she need to get? So I'm going to start with the area and taking the 17 feet times another 17 feet times 20 feet will give me the area. I don't have to actually even do this calculation. I just know I have feet and feet. That makes square feet. So then I use this information. 1 can of polyurethane is 1 coat over 150 square feet. So I can do that this way. 1 can is 1 coat and 150. So it's kind of both per coat and per 150 square feet. So that'll cancel out the square feet. And she wants 3 coats. So you could start with something like 3 coats and then maybe like one coat is 150 square feet, and then multiply that by one well, yeah, I need to also do one just a sec. Right, and now you really can't split it up that way. So it has to be the 1 coat over 150. So it's 1 coat of 150 square feet. Essentially, those are together. But what you could do then is just put it as the 150 square feet to 1 can. And just kind of note that's 1 coat, so that takes care of the coat unit. Or you could just figure out, just for 1 coat. So never mind the coats, set that aside. 1 can covers 150 square feet, and then say, but we want to do that 3 times over. Somewhere in there include the multiplying by 3. Okay, so taking 17 times 20 gives the area of the floor divided by 150 to figure out how much is covered by 1 can, or essentially that would give how many cans to get 1 coat, and then multiply by 3 to get how many cans to get 3 coats. So, all right, 17 times 20 divided by 150 times 3. Now, you might find it easier to just break this down, not worry about the dimensional analysis process. You can probably figure out, 17 times 20 to get the area, and then you can figure out how to get from there to the number of cans, just using kind of common sense, intuition, experience, whatever. It comes out 6.8. So she can't get part of a can. She has to go up to 7 cans. Now, even if it was 6.1, she would still need to get 7 cans. So in this context, you will round up regardless. So you won't be following regular rounding rules. All right, then number 30, Josh built an in-ground pool in the shape of a rectangular prism, so basically a box shape. So it's equal depth throughout. The pool is 3 yards wide, 7 yards long, 2 yards deep. We want the volume of the pool in cubic feet. So I can take 3 times 7 times 2, and that'll get me my cubic yards. And then I want to convert to feet. So 1 yard is 3 feet, but I need cubes. So I'll cube the yard, cube the 1, cube the 3, cube the feet, and the cubic yards cancel. So I'm taking my 3 times 7 times 2 times 3 cubed. Another way to go about it is do it as 3 yards times 7 yards times 2 yards, and then do a conversion 3 feet over 1 yard. That takes care of one of the dimensions. Do it again, 3 feet over 1 yard, and then one more time to convert all of the yards to feet. Now you could also do 3 yards, convert that to feet, and then 7 yards, convert that to feet, and then 2 yards, convert that to feet. And then still you're multiplying those all together. You don't have to do the individual calculations and write them down. So in some combination, we have 3 times 7 times 2, and then times 3 times 3 times 3. But those can be done in whatever order makes sense. So 3 times 7 times 2 times 3 times 3 times 3. 1134 feet. All right. Then Josh's pool has an algae problem. Each bottle of algicide treats 350 cubic feet of water. So I have my 1134 cubic feet, and I have one bottle is 350 cubic feet. Even here, I'm making sure I have my cubic feet here and put the cubic feet on the bottom. So I'm going to divide the 1134 by 350. And that comes out 3.24. But this is probably, I gather from people that have pools, algae can be a real problem. And it's one of those things, kind of like when you're taking antibiotics, if you stop too soon, it'll just come back worse and stronger. So he doesn't want to just get 3 bottles. He doesn't want to round down. He wants to go up and get 4 bottles to make sure that he has the full amount that he needs. And then each bottle of algicide costs $5.79, so he's getting 4 bottles at $5.79 per bottle. Even here, the dimensional analysis process is still working. You may not need to use it, but it's still there in what the units are doing. So taking 4 times $5.79, he needs to pay $23.16. We're not worrying about tax. Obviously, he would actually have tax added on. We'll assume the $5.79 includes tax.